Hello, friend. Myself, Sanjeev Divedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this session of Java. In this particular session, we are going to talk about uh, conditional statements in Java. Like, I mean, we must be knowing if else, nested if else, and switch statement. I know you are aware of these, but then this is just an overview of what if statement says. Now, when it comes to if statement, here we will have a condition. So if the condition is true, the if block will get executed. So if the condition is false, we are not specifying the code to be executed in case the condition is false. So if statement is simple selection statement, it checks the condition and then the particular block of code is executed. This is simple. I value is 10. If I say I is greater than 15, then the output will be 10 is less than 15. And if the value of I greater than I, which is 10, if it is false, in this case, it will be false. So we'll say I'm not in if. This is how it goes. So it's like if the statement is true, the block will be executed. If the statement is false, the block will not be executed. This is simple if statement. Now in if-else statement, we are specifying two block of code. If the condition is true, we'll specify the block of code to be executed. If the condition is false, we'll specify another block of code to be executed. So if true, then if block, else block. This is how the if-else statement goes. And a simple example, if I is less than 15, then output will be I smaller than 15. Else, if the value I is 10, which is less than 15 is true. So in this case, output will be I smaller than 15. Now, suppose if the value of I is 20, then I less than 15 will be false. In that case, my output will be I is greater than 15. So this is about if-else statement. Nested if-else means what? We can nest if-else statement within if block or within else block. This is how nested if-else goes. So here, if condition 1 is true, then it will check condition 2 is true. Is that clear? So this is about, so in this, if we have nested another if block, so we can nest else also here. And even in else block, see, it can be something like this. It can be something like this. So if we have if, and within if we can have if, we can have else, and for this if we can have else, and in that case we can have if, or we can have else. So we can have a complete if else nested within other if else. So this is about nesting of if else block. And yeah, for example, I've initialized the value of I with 10. If I is equal to 10, in this case it is true, then it will check. If I less than 15, so in this, if we have another if, I less than 15 true, so the output will be I smaller than 15. Now suppose the I value I have initialized with 20. I is equal to 10, no. So here if will not be executed. And then uh, this if ends here. So this cells I is greater than 50. So in this if block, we have this if, and then else here. So if the value of I, let's say, is, suppose the value of I is 13, I equal to 10 false. So this if, see, this if is different, I less than 15, and this if with else. So this is one block. See, so if I is 10, no, तो यहाँ पे आउटपुट ही नहीं आएगा. बट सपोज अपने केस में I का वैल्यू क्या है 10, is I equal to 10? Yes. Then I less than 15, true, output will be I smaller than 15. So if nested if will only be executed above statement is true. यहाँ पे ये अगर ट्रू हुआ तो ही कंट्रोल अंदर चेक करेगा. अगर यहाँ पे ट्रू नहीं है तो कंट्रोल अंदर चेक नहीं करेगा. This is what it means by nested if else. So it's like a block. If this particular door can be opened, then only this door can be accessed. Nesting. And We have Lcflatter. So if you have multiple statement to be compared with, if we have multiple option to be compared with, then we can have if-else ladder. So here we have if the condition is true, the statement is executed. Sorry, if the condition is true, the statement will be executed. Else, if another condition is checked, if true, then the statement will be executed. And if none of the if conditions are true, then else statement will be executed. This is how Lcflatter will work. Just have a look. I value is 20. Is I 10? No. So then goes to else. Suppose I is 10 here. Then I is 10, yes. I is 10 print होके output बाहर आ जाएगा. Now I is 20 here. So is I 10? No. The control goes to else. If else I is 15? No. Control goes to else. If is I is 20? Yes. The output will be I is 20. Now suppose I is 25 here. Is it equal to 10? No. Is it equal to 15? No. Is it equal to 20? No. Then output will be I is not present. This is we can have if we need to have a multiple option to be checked, multiple options to be compared with, then we can include the else if ladder here. Now break statement, this is very important. Break statement basically terminates the control, terminates the loop and takes control outside the loop. Now just to demonstrate you, now have a look here. So here we have an array with the index position 0, 1, 2, 3, 4. Now for int x equals to numbers, take care. If x is 30 break, so now this is kind of for each loop. So it's like for each integer x in the array numbers, this is how it goes. For each integer x in the array numbers, if the value of x is 30, then break. So the first integer is 10. It says for each integer x in array number, this is how it reads. For each integer x in array numbers. It checks. So first integer is 10. Is it equal to 30? No, nothing. So this is for each. No? This is for each. So the loop will get executed repeatedly executed. Then x is 20. Is it equal to 20? No. Break will not get executed. Okay. So this is if, sorry. So this for is here. This if is here, then for is here. We should have another. Okay. So for each integer x in number, is x equal to 30, then break, else print x. So 10, is it equal to 30? No, so it prints 10. Then 20, is it equal to 30? No. Then 30 is equal to 3, yes, break. Break means control will come out of the for. So when break loop get executed, it terminates, when break statement get executed, it terminates the current loop. Now, what do you mean by, when I say current loop, it goes something like this, and it takes control outside the current loop. Now it takes out control outside the current loop. It is something like this. Now suppose we have nesting. So we have for loop, and in the for loop we have another for loop. Now the point is, if break statement is executed here, the break statement is executed in inner loop. So it will terminate the inner loop. The control will come out here. However, if break statement is executed in outer loop, then it will terminate the outer loop and control is transferred here. So what you should remember is when break statement is executed, it terminates the current loop and takes the control outside the current loop. So this is about break statement. So here there are no further iteration possible in the loop. So if loop was supposed to execute 10 times, break statement is executed for I equal to 1 to 10 may, break statement is executed at I is equal to 2, then all other iteration for I 3, 4, 5, 6, 7, 8, 9, 10 are terminated. It won't happen. This is about now continue. What it does is it takes the control back to the beginning or next iteration. Basically it takes the control to the next iteration. Now what it simply says, see, it takes control to the next integer. So this is my array. So for integer x in numbers, if x is equal to 20, continue means what? First x is 10. Is it equal to 30? No. So continue will not get executed. X is printed 10. Then next integer is 20. Is it equal to 30? No. Continue will not get executed. Print x. So it will print 20. Next integer is 30. Is it equal to 30? Yes. Continue will get executed. So it moves to the next integer 40. So this print statement is bypassed. It's like for that iteration, the loop is, but the iteration is terminated. So I mean, it's simply like that. For I equal to 1, I less than equal to 5, I plus plus, and if I equals to 2, I said, and then I said break. Okay, sorry, continue. And if I say system.out.println hello, now what happens here is I will be 1. Is it equal to 2? No, continue will not get executed. Hello is printed. Correct. I become 2. 2 less than equal to 5. Yes. Is it equal to 2? Yes. Continue gets executed. Now hello will not be printed, directly transferred to the next iteration of the loop. I become 3. So here for I equal to 1, hello is printed. I equal to 2, it will not be printed. Then I become 3. Correct. Is less than equal to 5? Yes. Is it equal to 2? No. Again hello is printed. So break, basically it does not terminate the loop. Had it been break for I equal to 2, if I write break, then I equal to 3, 4, 5 is not possible. Now what happens in continue is, if for that iteration continue get executed, then the control moves to the next iteration of the loop. This is how the continues work. Now continues plays very important role when it comes to asking question with respect to find the output. Then we can have interesting questions on this. This is switch case. Now switch case is similar to if else. Ideally a switch case is similar to if else, but we can only go for equality comparison, and the variable can only be integer or character. So remember, it is ladder. If switch behaves like if else ladder, but with certain condition. The condition is only equality will be compared. Only equality and compare, and the variables will be integer or character. This is how it is simple. This, so it's like it will, the expression, the value will be compared, the expression value is compared to case value 1. If true, block 1 is executed, break, and control is moved out. If expression is not equal to value 1, then it is checked with value 2. If true, block 2 is executed, break will take the control outside the switch. Now if none of the above case values are executed, then default block is executed. This is how we can use switch case, like the way, I mean, we discussed key by, it is used when we have multiple options, multiple alternatives, which was similar to Lcflatter. In Lcflatter, within if, we can go for any type of comparison, like a greater than 5, c greater than d. But in case of switch, when we want to convert the Lcflatter to switch, we can only do that if that condition is checked for equality. So this is what about if else. Remember, we can see every, it's like every switch can be converted to if else ladder, but every if else ladder cannot be converted to switch. So here we have number is 20, it will set switch number is 20. Is it equal to 10? No. 20, yes. Output will be you are in 20 and break. Now had it been 30, is it equal to 10? No. 20, no. 30, yes. You are in 30 and break. Now if it is 5, is it equal to 10? No. 20, no. 30, no. Default will be executed. The output would have been, it is not in 10, 20 or 30. So this is about switch case will look like when we have, like the way we discussed, when we have multiple options. Now this is a special type of for loop we have already seen in case of break and continue. Uh, See, if I'm supposed to write a corresponding for loop for it, then it would have been something like this: for int I equal to 0, I less than, let's say 10 here, I plus plus, and I could have printed SOP. I could have printed a of I, whatever the array is. Here the array name is nums. So I could have written SOP nums of I, and then what it says, sum is sum plus a of I. So if I would have written this program using for loop, the for loop we know, then this is how it will be. It like int I equal to 0 to 10. So in for loop we need to specify the start position and end position of the array element to be accessed. And then here the integer I specifies the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are indexed. Now, what happens in case of for each? We don't have to specify the first range, just the range. It's like I'm saying for every student in a class, they can move out. So I'm not specifying the range from index position this to this. So it's like this is how it reads for each integer x in array nums. And this x is not index here. This x is element. So here x value is initially 1, then 2, then 3, then 4, and so on, and then it will be added. So here when I say int x, x is not the index, x is the element. But here when I say int I, it identifies an index in array. So this is the difference between for and for each here. We can see the syntax. See, for data type, just say int variable a in array or collection. So actually, for each is basically used in collection, because in collection we they grow and shrink dynamically. What array happens is array is static in nature. It cannot grow, it does not grow and shrink dynamically. So we have a range that from this position to this position. But when it comes to collection, we will talk about collection. We will have vector, we will have array list, and so on. Basically it's like the elements are added at runtime and removed at runtime. So it is growing and shrinking. So typically specifying the range from this position to this position for all the element becomes difficult. So in such cases, we can make use of this special for loop. We call it as for each loop. So this is about for each loop. So this was about the control structure. Basically, when we are talking about if else ladder, nested if else switch, we also talked about a special type of for, which is known as for each. I hope this session was useful to you, and you can refer Herbert Schill complete reference for further detail on this topic. And thank you very much. Enjoy learning.